Okay, good morning. This is week 10. Today we have a very long day or long 3 hours. We're going to do 2D Mohr circle, and then we're also going to carry on 3D Mohr circle within 3 hours. I hope. If not, we'll do it next week also. Quiz 6 will be available on November 15 to November 19. Okay, so just be aware. Okay, so I believe most of you have seen or some sort learned Mohr circle before, either in college or in university. Those of you who are taking 3CO3Me, there's some repetition over here. Maybe if the first half an hour, the rest will be new. Okay, so but before I go on, can anyone tell me why we need Mohr circle? Anyone? Or what is the purpose of Mohr circle? Anyone? I don't hear nothing. Too early. Okay. So let me start with why do we need Mohr circle? And let me start with that first. So why do we need to learn Mohr circle? I think Mohr circle is one of the most important tool in structure analysis. Okay, why is that? Okay, why I say it's the one of the most important thing. Okay, so let's look at material testing. Okay, material mechanical properties. Okay. So we carry out tests tests are carried out. Okay, tests are carried out to determine mechanical properties, right? We know that. But all these tests, or most of these tests, are tested in one direction only. Okay, so the tests are either in. So this is the specimen. So the tests are carried out in. So tests are carried out. Tests are in unidirectional. So what do I mean by unidirectional? So they can carry out tests in tension, which is most common. Okay, so if you look at materials handbook, you have tension. Okay, and then or you can have compression. And sometimes, if we are fortunate enough, okay, it's in shear. Okay, so shear, you carry out torsion tests. Okay, so I'm going to go into a textbook to show you what I mean. Okay, so if we go into a textbook, that we use. Okay, so this is a typical textbook. Okay, and then if you look at the last few pages, okay, if we look at the last few pages, okay, yeah, over here. So let's look at something that is in SI units. So what you can see is you can have they quote ultimate strength, okay, in tension, in compression, or in shear. Okay, so if your structure is in tension, you look at this property over here. If it's in compression, okay, if it's on shear. And then what I like about this book, they also give you U strength, okay? So U strength in tension and U strength in shear, right? So it is separated is because it's all carried out in unidirectional, okay? One direction only. So as I said, the test can be carried in either tension or in compression or in shear, okay? But what are these all these value, okay? Later I'll elaborate what they are, okay? So that we know that they are unidirectional, okay? Then we look into the actual loading of a structure. Okay, we look into the actual loading of a structure. So in actual load, so I'm going to draw a so-called a 3D structure. Okay, I'm going to draw a 3D structure. Okay, not a very good, yeah, but it's a structure. Okay, so it has its axis over here. There's another axis over here. All right, and this structure is mounted at the base. Okay, and this structure is under a load. So if I were to draw my transformation, it's our x, y, and z. Okay, so if the structure is under a load over here, and this is our Py, and then we are given that this structure, okay, is also loaded in the Px direction. Okay, so the loading on the right hand side is your actual structure. It's not unidirection, right? So the structure is non unidirectional. Okay. All right, it's non unidirection. So now you are going to calculate the stresses, okay, on an element. Okay, I'll show you. This is known as an element. Okay, element is a location of interest. Okay, measured using strain gauge. Okay, that is what we call an element. Okay, so likewise for tension and compression, what is common is an element. Whenever we do any measurement, okay, we like to put a strain gauge, right? So now on the left hand side is the test condition, right? So you got the test condition. So after the test, let me go back to this table. Okay, so after the test, what we tend to do is we will have we generate a table like this, right? We generate a table like this. Okay, so from a table like this, one, right? We generate a table like this, and this table is generated from unidirectional data. Okay, unidirection, one direction, right? You can see down here. All these are one direction data. But is our loading situation unidirectional? So it is not unidirectional. So how are you going to use this data? Right? When I was working Rolls-Royce, all I did is, okay, just take the one that has the highest stress component and just compare with the material property. That is wrong. Then we rely, okay, we are going to rely on finite element simulation for it to be more accurate. Good. Yeah, I was working for Rolls-Royce. We could afford finite element, okay? Most of the companies that you guys are working now, or you guys will be working for, cannot even afford the license, because the license is about $250,000. Okay, so how to relate both of them is, you can relate both of them. Okay, relate using Mohr circle to determine principal stress. Okay, so the first thing you learn now is the term principal stress. Okay, so let me define what is principal stress. So principal stresses have zero shear stress component. Okay, so what you see down here, okay, so what you see, let's ignore the ultimate strength. Okay, let's focus on the yield strength. Okay, so what you see down here, okay, what you see down here, they are all your principal stresses. Right? And I can show you why. Okay, I can show you why now. So if we were to take out one of the element, okay, so so now what I'm going to do is I'm going to extract the element, okay, and I'm going to show you briefly Mohr circle. Okay, so this is the element under tensile loading only. Okay, under tensile loading only. So we have an element, and we know the element is under tensile loading. Okay, let me change the view. Okay, so we have an element, so I'm going to draw our transformation. Okay, I'm going to call this X and Y. So our structure is under uniaxial loading. So this is stress in the X direction. Okay, so coming back to this diagram over here, so this is our X, this is our Y, and over here, wrong direction, I do apologize. There will be our Z. Okay, so I've just drawn this relating to the real world. What is an element? So there's our stress X in tensile. So usually I have a habit, or I want you all to train you all to have a habit. On the element, we label this as X, and the Y plane, or the plane intersecting the Y axis, as Y. Okay, So now I'm going to construct Mohr circle. I'm going to draw Mohr circle now. Okay, we are going to draw our first Mohr circle. Okay. So on Mohr circle,